Hello students, today we will discuss about the physical properties of aldehyde and ketone. First one, we will discuss about their state. In which state? In solid, in liquid or in gas. So students, methanol, it exists in gaseous state. It exists in gaseous state at room temperature. Ethanol, ethanol, ethanol is volatile liquid. Volatile liquid. Other aldehyde and ketone either may be liquid or solid. Other are existing in liquid and solid state. First thing students, methanol, it is also known as the, what is the other name of this? Formaldehyde, HCHO. Due to its small size, due to lesser number of the carbon here van der Waals force of attraction is very less. Okay, due to which it exists in gaseous state. Then, if I move to the ethanol, ethanol is also known as the acetaldehyde. Acetaldehyde, its common name it is. Its formula is CH3CHO. 2 carbons are there. So here number of carbon increases. Due to increase in number of carbons, so their attraction may be increases. Van der Waals force of attraction may increases. So you know very well attraction is very less, means least attraction in case of the gaseous molecule. Then when we move to gaseous to liquid, then force of attraction increases. Okay. Then ethanol, because there are 2 number of the carbon, so van der Waals force of attraction increases as compared to attraction in methanol. Then it is liquid, but what type of liquid? It is volatile, means it can be easily converted into the vapors. Easily convert into the vapors. Then if we further move to the higher aldehydes like propanol, butanol, so up to 5, they may exist in liquid state. They may exist in the liquid state. And after that, number of carbon will increase, then van der Waals force of attraction increases. Due to increase in the attraction, they convert it, means they exist in the solid state. So higher aldehyde and ketone exist in the solid state. Okay, up to butanol and pentanol, they may exist. They may exist in liquid. Means if number of carbon atoms increases, then van der Waals force of attraction. Van der Waals force of attraction increases. Why it is? Because surface area increases. Van der Waals force of attraction increases. Due to increase in van der Waals force of attraction, they convert into the gaseous to liquid, liquid to solids. Means if number of carbon atoms, the higher aldehyde and ketone exist in solid state. It is clear to you or not? Then if we talk about their smell means odor. Lighter aldehydes and ketone like methanol, like acetone, okay, they have, like methanol, they have pungent smell. Pungent smell means it is very bad smell. We cannot smell it. Okay, means It is very difficult to smell it. It is very bad. So pungent smell, tikhi we can say, and higher aldehyde and ketones. Higher aldehyde and ketone smell. Higher aldehyde and ketones, they have sweet smell, like fragrance. So students, in first of the unit, in starting of unit, I have told that aldehyde and ketones are used for making flavors, perfumes. Okay, so those which aldehyde and ketones we can use for making perfumes and for flavors. Higher aldehyde and ketones we use. Okay, lower aldehyde and ketones, methanol, acetones, we do not use them because their smell is very bad smell. They have so pungent smell. Okay, means that like smell. Sometimes we smell anything. Some water fall down from our eyes. पानी बहता है ना कई बार, मतलब किसी चीज को स्मेल करने से वो तीखी स्मेल होती है. That is known as pungent smell. Okay, so lighter aldehyde and ketones have pungent smell, but higher have sweet smell. So in flavor and in perfumes, we use the higher aldehyde and ketone, not lighter. If we talk about the boiling point, if we talk about the boiling point, you know very well some basic things. Boiling point directly proportional to the molecular mass. If molecular mass increases, means molecular mass, or we are studying about the aldehyde ketones. Okay, means hydrocarbons, we can't say that, but carbon and hydrogen must be present there. Okay, so here if number of carbon atom increases, then boiling point increases. Means if molecular mass increases, then boiling point increases. It is directly proportional, but it is inversely proportional to the branching. It is inversely proportional to the branching, and it is directly proportional to the surface area. By this, we can compare aldehydes to aldehyde only, ketone to ketone only. Okay, but if we want to compare with other molecule, like if we want to compare boiling point of aldehyde with the boiling point of ether, boiling point of hydrocarbon, so what will be the trend? We will see that. In simple, if we want to compare aldehyde to aldehyde, ketone to ketone only, then what concept you will see? First one, you will see the molecular mass. If molecular mass increases, then boiling point also increases. It is directly proportional to this. And if number of carbon increases, then also boiling point increases. It is directly proportional to surface area also, but it is inversely proportional to the branching. But student, if we want to compare boiling point of hydrocarbon, we have ether, we have alcohol, we have ketone, aldehyde, then what will be the order? What will be the order? Here, ketone have more boiling point, slightly high boiling point as compared to aldehyde. And aldehyde have high boiling point as compared to the ether. It has high boiling point as compared to the hydrocarbon. Okay. Then alcohol has highest boiling point in between them. Why it is? Because here in alcohol, you know very well, hydrogen bonding, intermolecular hydrogen bonding, they form. For example, if I have two molecule of the alcohol, ROH, and second molecule, this. So they form hydrogen bonding. They form hydrogen bonding. Due to intermolecular hydrogen bonding, in between molecule of the alcohol, they have maximum boiling point in between these. Clear to you or not? Then students, if I compare ketone and aldehyde, alcohol has more boiling point as compared to ketone and aldehyde because they form the intermolecular hydrogen bonding. But if I compare ketone and aldehyde, a little bit difference is here. But ketone is more. Why? Because they show dipole-dipole interaction. Both aldehyde and ketone show dipole-dipole attraction. Dipole-dipole attraction they have. Here dipole, like I have CH3 COH and I have CH3 you know very well, after charge separation, oxygen is more negative, so negative charge will goes on this, positive will goes on this, positive will goes on this, negative will goes on this. So here positive and negative, they form some interaction between them, and that is known as dipole-dipole interaction. Both show the dipole-dipole interaction, aldehyde and ketone. But in case of the ketone, students, what happen? In case of the ketone, there are two electron releasing group present. So tendency to release the electron to oxygen is more. Clear or not? So here it show the high dipole-dipole interaction as compared to this. This attraction is strong here in case of ketone due to presence of two alkyl group, because alkyl groups are electron releasing group. In case of aldehyde, only one alkyl group is present here. Second one is the hydrogen. Clear or not? So here boiling point of ketone will be slightly higher as compared to the aldehyde. Why it is? It is due to presence of two alkyl group. Okay, and they have more boiling point as compared to the ether due to the dipole-dipole interaction, because they show dipole-dipole interaction between the molecules. Ether also show the dipole-dipole interaction but extent of interaction is less as compared to the interaction between aldehyde molecules and ketone molecules. And here in case of the hydrocarbon, here no dipole-dipole interaction, they are non-polar. So here what will be the order? Order will be the alcohol. I am talking about the molecules of the comparable molecular mass, beta. Comparable molecular mass. If I have alcohol, aldehyde, ketone, ether and hydrocarbon of comparable molecular mass, means their molecular mass would be similar. Okay, then what will be the order of their boiling point? Alcohol will have highest boiling point, will have maximum boiling point